Hello students, now we are going to discuss about the next chemical property, that is Hofmann's exhaustive alkylation. So let's start with our next chemical property for amine, that is alkylation of amines, and the reaction is also known as Hofmann's exhaustive alkylation. The very first question, what is alkylation? Alkylation is nothing but introduction of an alkyl group. Then what is exhaustive alkylation? Let's see this. Exhaustive alkylation means over alkylation or alkylation in excess. So now what we are going to do, our main aim is removing one hydrogen and adding one alkyl group, and therefore the entire reaction is known as alkylation of amines. Let's see this reaction. For this, let's take a primary amine, that is RNH2, and to this what we would do, we would add a molecule of RX, that is alkyl halide. Now what happens? Nitrogen consists of one lone pair, and if this one lone pair attacks over to the R group, because R is a partially positive species, that means R is undergoing a nucleophilic attack, then what would happen? We would have the RX bond broken down, X removed as X negative, and H from amine is removed as H positive. So what we are going to get? We are going to get HX that would be formed. And now, after this, what we are remaining with? We are remaining with a compound in which nitrogen is attached to two R groups. That means we are having a secondary amine. And now, in this, have we introduced one alkyl group? Yes, we have. And therefore, the reaction would be rightly called as an alkylation reaction. Now, let's see why exhaustive. Let's add one more RX to this. Again, what would happen? Again, nitrogen would move for an nucleophilic attack. Again, you would get HX. But now you would get a compound in which nitrogen is attached to three R groups. That means a tertiary amine would be obtained. Now, we are not stopping the reaction over here. Let's continue this. Let's add one more RX into this. What would happen now? Again, nitrogen would donate its lone pair towards R, and now we would get a compound in which nitrogen, the central atom, is attached to four R groups, but now nitrogen has a positive charge, and to this X negative is attached, and therefore we can write this as R4N X minus, which is a quaternary ammonium salt. Now, a very important name is also known as tetraalkyl ammonium halide. Let's see the next point. This entire reaction which we have seen as of now is an example of an SN2 mechanism. And the further point, if excess of alkyl halide is used, the mixture of different alkylated product is avoided. And who would be the major product? The major product would be tetraalkyl ammonium halide. And this reaction is therefore known as exhaustive alkylation of amines. Let's see further. Let's take one more example. Suppose we take a primary amine. Then to this we are adding 3 moles of CH3I. What we would get? We would get a compound in which nitrogen is now attached to one R group and 3 CH3 groups. That means a quaternary ammonium salt. But for the students, if it was a primary amines, remember we have used 3 moles to get a tetraalkyl ammonium halide. Similarly, let's take a secondary amine. To this, again we are adding CH3I. But now, if we want a quaternary ammonium salt, how many moles should be used? It should be 2 moles. And lastly, if we take a tertiary amine, and to this we add CH3I, then remember we need only 1 mole. for getting a tetra-alkyl ammonium salt. Also, the excess of HI in this entire reaction which would be formed in this case is neutralized using NaHCO3, that is basic in nature. So this was all for this module, students. We would meet in the next module. Till then, thank you.